Hi, everybody. Today is May 20th, and we're going to talk about half-angle identities today, okay? So from yesterday, we saw that cosine of 2 theta is equal to 2 cosine squared theta minus 1, right? And if you look at this angle is twice this one, right? So if we go from here and look at this angle, this one's doubled, right? Or doubles, okay? But you can look at this another way, okay? This angle right here, if this angle's twice this one, then this one has to be half of this one. So if we look at 2 theta and go here, this one is half of this one, okay? So if we go from here to here, it's halved. If that's even a word. Don't tell Mr. Castle, okay? So another way that we could write this is cosine of theta is equal to 2 cosine squared of theta over 2 minus 1. And that, folks, is how we're going to get the half-angle identities, okay? So what we're going to do to get this one, okay, and this one's going to become cosine of theta over 2. So we need to solve this for cosine theta over 2, okay? So we're going to add 1 to both sides. So that'd be cosine theta plus 1 is equal to 2 cosine squared of theta over 2. And then we're going to divide both sides by 2, and that will get rid of this 2. So we'd have cosine of theta plus 1 over 2 is equal to cosine squared of theta over 2. Okay? And then what we would do is we would square root both sides, and that would get rid of the square, and we'd be left with cosine of theta over 2. Now, I'm going to skip this part. Whenever we square root a square, right, a perfect square, we get absolute value. But we always get plus or minus, right? So I'm going to jump right to that, okay? So, well, actually, I'm going to put this one on the left-hand side. Okay, so cosine squared of theta over 2 is equal to, and I'm going to write this as 1 plus cosine of theta over 2, right? And then, okay, so we're going to square root both sides. That will get rid of the square. We'd be left with absolute value, but then we're going to get plus or minus, right? So in essence, this becomes cosine of theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2, okay? Now, I want to say something, okay? This does not mean that every single problem is plus or minus. No, the answer could come out to be positive, but it could also come out to be negative, okay? We're going to pick the positive or negative depending on where theta over 2 lands, okay? So well, we're going to go into this later, okay? But if this theta over 2 were if it happened to be in the first quadrant, right? If the angle theta over 2 were in the first quadrant, then we would pick the positive one, okay? And it would just be positive square root of 1 plus cosine theta over 2, okay? If this angle theta over 2 happens to be in the second quadrant, then we would pick the negative because cosine is negative in the second quadrant, okay? And that's how we're going to determine whether it's positive or negative. So I don't want you to think, oh, it's both. No, it's either one or the other, okay? So over here, we're going to do the same thing, okay? So if this angle's twice this one, then we could also say that this one is half of whatever this one is, right? So we would have, in this case, cosine of theta is equal to 1 minus 2 sine squared of theta over 2. It's just another way of writing the relationship between these two, okay? Instead of doubling it, right, we're saying this one's half of this one, okay? All right, so now we're just going to solve this for sine theta. So we're going to subtract 1 from both sides. Okay, actually, I take that back. I'm going to move this minus 2 sine squared theta over 2 over to the left-hand side, okay? And I'm going to move the cosine theta to the right-hand side. So I'm going to do that in like one step, okay? So I'm going to add 2 sine squared theta. So that gives me 2 sine squared of theta over 2 is equal to 1, and I'm going to move the cosine theta over to the other side. So minus cosine of theta, and then I'm going to divide both sides by 2, and we would get sine squared of theta over 2 must equal 1 minus cosine theta all over 2. And then again, I'm going to square root both sides. This would give me the absolute value, which would give me plus or minus, okay? So sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2, okay? So again, this doesn't mean it's always plus or minus. It's either going to be positive or it's going to be negative. It could be one or the other, okay? All right, so here we go. How are we going to pick this? Okay, the way we're going to pick it is where theta over 2 lands. If theta over 2 is in the first quadrant, if that angle's in the first quadrant, then we're going to pick positive because sine is positive in the first quadrant, okay? If we pick theta over 2 and it's in the second quadrant, it's still going to be positive because the sine ratio is positive in the second quadrant. If theta over 2 winds up being the third or the fourth, the bottom two quadrants, then that's when we would use the negative, okay? All right, so that's it with the plus or minus, okay? We also have a half angle identity for tangent, okay? So I'm going to slide this up, and it actually is going to come from these two put together, okay? So what we have is tan of theta over 2 is equal to, and tangent, okay, is the same as sine over cosine. So this would be sine of theta over 2 over cosine of theta over 2. And so we can replace this numerator with the plus or minus, right? The plus or minus the square root of 1 minus cosine theta over 2 all over plus or minus 1 plus cosine theta over 2. This, when you take the square root of a fraction, this could be plus or minus. And I just made a mistake. Okay, when we square root a fraction, we can square root the numerator and square root the denominator. I started to write it as one big fraction, okay? I actually want to separate this. This would be 1 minus cosine theta over the square root of 2. Here's my main fraction bar. It's in line with the equals. And then this would be plus or minus 1 plus cosine theta over the square root of 2, okay? But now we have a complex fraction, right? So we can multiply top and bottom by the square root of 2. So that's what I'm going to do next. The square root of 2 over the square root of 2. That's a version of 1, okay? But what that's going to leave me with is tan theta over 2 is equal to plus or minus the square root of 1 minus cosine of theta over plus or minus the square root of 1 plus cosine of theta, okay? And really, we don't need the plus or minus over the plus or minus because plus or minus over plus or minus is just simply plus or minus. So this is equal to plus or minus 1 big square root and 1 minus cosine theta over 1 plus cosine theta. Okay, now how do we determine it whether it's going to be the positive one or the negative one? Okay, so one way to do this, okay, is to determine, okay, where is theta over 2, what quadrant that is in, and then if you determine what quadrant that's in, then determine what the sign of tangent is in that quadrant, okay? So if theta over 2 is in the first quadrant, okay, tangent in the first quadrant is going to be positive. We'd pick the positive one. If theta over 2 was in the second quadrant, tangent's negative in the second quadrant, so we pick the negative one, right? If this theta over 2 were in the third quadrant, the bottom left, well, in that quadrant, tangent is positive because it's negative divided by negative, and so we'd pick the positive one, okay? And if theta over 2 were in the fourth quadrant, then we'd pick the negative one, okay? Because in the fourth quadrant, tangent is negative, okay? Hopefully you understand that, all right? Okay, so here's the bad thing. There's two other versions of this, Okay, so if we start out, okay, so this is one of them. I'm going to highlight this one. This is one version of the half angle identity, okay? I'm going to highlight this one. This is one. This is the half angle identity. There's only one for cosine, and there's only one identity for the half angle identity for sine. Okay, so there's another version of this. If we start with this right here, okay, so if we start with this plus or minus the square root of 1 minus cosine theta over plus or minus the square root of 1 plus cosine of theta, and we multiply by a version of 1, and we do this, the square root of 1 minus cosine theta over the square root of 1 minus cosine theta. Okay, so this is the same as this. Okay, so then I'm saying, okay, I'm going to take that, right? That's this one. And I'm going to multiply by a version of 1. Okay, now what this is going to give me is it's going to give me a perfect square right here, okay? And so I'm going to be left with 1 minus cosine theta times 1 minus cosine theta. And if I do that, I'm going to get 1 minus cosine theta squared, but I'm square rooting it, right? So this top becomes 1 minus cosine of theta. This bottom, if I multiply it, becomes 1 minus cosine squared theta. Because if I multiply these, I get 1 times 1, which is 1 times negative cosine theta, positive cosine theta times 1. So the negative cosine theta and the positive cosine theta are going to cancel, and then I'm going to have cosine theta and a negative cosine theta, which makes the negative cosine squared theta. But heck, this is a Pythagorean identity, right? Okay, so this becomes sine squared theta. So 1 minus cosine theta over the square root of sine squared theta. And that's going to become just sine theta, okay? So this becomes 1 minus cosine theta over sine theta. Now, I'm going to say something. We're not going to have to worry about the plus or minus. I kind of stopped writing. I didn't talk about it. This, okay, again, this could be, okay, and this would be a proof that we would need to do, and I'm not going to do it for you, okay? But theta over 2, whatever determines that, this would always have the same sign of whatever tangent is for that angle. So we don't have to worry about it being positive or negative. It will always give me the same sign that I need, okay? So for this one, we don't have to worry about whether it's positive or negative. Whatever we get for cosine of that angle and sine of that angle, we'll get the right sign, okay? All right, if I do something very similar, and instead of multiplying by 1 minus cosine theta over 1 minus cosine theta, actually, heck, let me do it, okay? Plus or minus, so we're going to start with the same thing. Okay, instead of this version of 1, I'm going to do this version of 1 plus cosine theta. Okay, so when I multiply this, I'm going to get a perfect square, because both these things are the same thing, and then the square root will take care of the square. So I'm going to be left with 1 plus cosine theta in the denominator. If I multiply this out, I'm going to get 1 minus the square root of 1 minus cosine squared theta, but that's sine squared theta over 1 plus cosine theta. All right, and then that's going to give you sine theta over 1 plus cosine theta. And I'm going to tell you it doesn't matter the sign. The sign will be taken care of in this identity, okay? This identity always has the same sign as whatever tan theta over 2 is, okay? All right, so for tan theta over 2, okay, that could be equal to plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. But we have to determine the sign, because here's the thing, square root's always positive, okay? If we square root something, it's going to be positive. So that's why we need the plus or minus, okay? But over here, these are sometimes positive, sometimes negative, depending on the angles, and everything gets taken care of within this, okay? Okay, so another version of this is 1 minus cosine theta over sine theta, or sine theta over 1 plus cosine theta. I actually like these two because you'll automatically get the right sign, okay? So here's the 3 versions of tan theta over 2 that you could use, okay? And I'm going to tell you, these are more useful, these two, okay? Because you automatically get the identity, okay? All right, now it's just a matter of doing some examples. That's all the theory behind it, okay? All right, so let's go do some examples. Okay, for this first example, use a half angle identity to find the exact value of cosine of 11 pi over 8, okay? So I'm going to write cosine of 11 pi over 8. Okay, but remember to find the exact value, okay, we need a denominator of 2, 3, 4, or 6. This is 8, right? Well, we can, because we could rewrite this as cosine of 1/2 times 11 pi over 4. Okay? All right, so this is my theta over 2, right? Okay, so now we're going to have to figure out, okay, what are we going to use? Is this going to be positive or is this going to be negative, right? Okay, so where the heck is 11 pi over 8? Okay, so 11 pi over 8. We know this is 0 pi over 8. And we know this is 8 pi over 8. And we would know, because this is 2 pi, this would also be 16 pi over 8, which would make this one 4, not 4, whoops, I was thinking up here, 12 pi over 8. We could go up here. Okay, this would be 4 pi over 8. 8 pi over 8, and this would be 12 pi over 8. Okay, so we have 11 pi over 8, right? So 11 pi over 8 is somewhere in between 8 pi over 8 and 12 pi over 8. That's in the third quadrant. Well, what do we know about cosine in this third quadrant? Well, it's negative, right? Okay. So this is equal to negative, okay, and let me write this. Okay, so 11 pi over 8 is in quadrant 3, right? And cosine of 11 pi over 8 is negative. And why is it negative? Because cosine is x over r, right? And in this quadrant, your x's are negative, okay? So that's why we're picking the negative one, and then we're going to do the square root, okay? And something else we got to remember, and let me do this. So this determine this sign right here, right? Okay. Now this is my theta over 2, okay? So if that's my theta over 2, right? This one right here is my theta. Okay, so my theta is 11 pi over 4. Okay, so I'm going to use the half angle identity for cosine. I know it's negative and it deals with the square root, and then it's 1 plus cosine of your angle theta. Your angle theta is not 11 pi over 8, it's 11 pi over 4 over 2. Okay, so now what we have to do is figure out what the heck is cosine of 11 pi over 4, right? Okay, so this would be 0 pi over 4. This would be 4 pi over 4. This is 2 pi over 4. Okay, so every one of these is 2 pi over 4s, right? So 4 pi over 4, this would be 6 pi over 4. This would be 8 pi over 4. This would be 10 pi over 4, right? If I'm counting, 10 pi over 4. this would be 12 pi over 4. And I want 11 pi over 4, right? So that means I'm in the second quadrant, right? Because 11 pi over 4 is somewhere in here. Okay, so actually what I'm doing is to get to 11 pi over 4, I'm going around once and then coming all the way to here, right? Now, my reference angle right here is pi over 4, right? And so I'm going to put the sides of the right triangle in. Because it's pi over 4, this vertical is going up, so it's going to be positive 1. This leg is horizontal, and it's going left, so it's negative. And this would be the square root of 2, right? Okay. So back over here, this is equivalent to negative square root of, and it would be 1 plus, okay? And what is cosine of 11 pi over 4? Will be negative 1 over the square root of 2. Negative 1 over the square root of 2. I'm going to do something in my head that I kind of want you to start doing. Negative 1 over the square root of 2 is equivalent to negative square root of 2 over 2. We should have seen that enough to just kind of know it. Okay, so negative square root of 2 over 2 all over 2, right? Okay, and I'm within this square root, and this becomes a minus. Okay, so I'm going to take a few steps to show you everything. Okay, so this is 1 minus the square root of 2 over 2. We have a complex fraction, so I'm going to multiply within this square root. I'm going to multiply by 2 over 2. That's going to give me negative square root of 2 minus the square root of 2 all over 2 times 2, which is 4, right? And when I square root a fraction, that's the square root of the top over the square root of the bottom. And the square root of 4 is 2. Okay, so this is going to be equal to negative, okay, the square root of 2 minus the square root of 2 all over 2. And that is the exact value of cosine of 11 pi over 8. Okay, all right, I'm going to grab my calculator because I want to show you this. Okay. Okay. So I want to show you that I'm going to type in cosine so you don't think I'm just full of it. Okay. Well, you can't think that. All right. But I'm going to show you that what I'm telling you, what I'm showing you is actually true. Okay. So cosine of 11 pi over 8, and we're going to get a decimal, right? Okay, so this is the decimal, right? What happens when we put this value in, right? So we get negative, and then fraction bar again, right? And then square root of 2 minus square root of 2 all over 2, right? And lo and behold, look what happens. Mr. Mitchell's not lying to you, okay? All right, they're the same thing. That's crazy, huh? And that's because this identity always holds, okay? All right. Now, what if we had picked the wrong sign? Well, we would have had the same decimal, but the wrong sign of the decimal, right? Because that negative is what's causing this one to be negative, right? Okay. And this one's negative. And the calculator, to be honest with you, the calculator is doing something. It's really doing an estimation. The calculator does not know how to find cosine of 11 pi over 8. Like there's some special way. It actually uses calculus to figure this out, okay? All right, and somebody has programmed calculus into this calculator, okay? All right, let's go on to example number 2. Okay, so use a half angle identity to find the value of sine to find the value. So I want to find cosine of theta over 2, okay? But I'm not going to give you theta. I'm not going to give you theta over 2. I'm just going to give you sine of theta is equal to negative 4 square root of 7 over 11, okay? Now, I am telling you that theta is between 3 pi and 7 pi over 2, okay? So to find cosine of theta over 2, okay, that's going to equal, all right, that's going to equal either a positive or a negative value, right? We don't know yet because we got to figure out where theta over 2 is. And let me tell you something, we actually can, okay? This says theta, it doesn't say theta over 2, but we can convert this to theta over 2, okay? So the way we're going to do that is we know 3 pi is less than or equal to theta, okay, which is less than 7 pi over 2, okay? Now this inequality holds if I multiply this by 1/2, this by 1/2, and this by 1/2, okay? So if I multiply this by 1/2, I get 3 pi over 2 is less than or equal to. If I multiply theta by 1/2, I get theta over 2 is less than, and then I know this one, if I multiply by 1/2, I get 7 pi over 4. Okay, so I know where theta is. Theta is between 3 pi and 7 pi over 2, but now I know where theta over 2 is. It's between 3 pi over 2 and 7 pi over 4, okay? All right, and we could convert this to fourths to really help us, okay? So this would be 6 pi over 4, okay? All right, I'm going to draw this in, okay, because we're going to figure out where theta over 2 is. Okay, so theta over 2 is between 3 pi over 2 and 7 pi over 4, okay? So this would be 4 pi over 4 right here, okay? And right here, this would be 8 pi over 4, right? And so the biggest we can be is 7 pi over 4, right? Okay, so 7 pi over 4, this would right here would be 6 pi over 4. But what's 6 pi over 4? 6 pi over 4 is really just this 3 pi over 2, right? So my angle, this theta over 2, has to be bigger than this one, but smaller than 8 pi over 4, or smaller than 7 pi over 4, right? So it actually is right here is 7 pi over 4. I'm purposely drawing a diagonal, okay? So it's somewhere in here, right? It's somewhere between 3 pi over 2, which is equivalent to 6 pi over 4, and 7 pi over 4. I know my angle is right in here, okay? Now, there's my right triangle. This isn't, we need this to determine, is this going to be positive or negative, okay? So right here, this angle right here is angle theta over 2. And it's in this fourth quadrant. And what do I know about cosine in that fourth quadrant? It's positive, okay? So we're going to use positive, all right? Actually, you wouldn't have to write the positive here. I'm just writing it to show you, okay? The square root of, okay? And it would be 1 plus cosine of theta over 2, okay? So to finally figure this out, I have to figure out what cosine of theta is, right? How can I do that? Well, I know that theta is between 3 pi and 7 pi over 2, and sine theta is negative 4 square roots of 7, okay, over 11, right? So this is telling me the y, and this is telling me the r, right? Okay, so where is 3 pi and where is 7 pi over 2? I'm going to draw kind of a big diagram here. Okay, so I know this is pi over 2. This is 2 pi over 2. This is 3 pi over 2. Okay, this is 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi, right? And right here, this would be 7 pi over 2, right? Okay, so this is equivalent to 3 pi. This is 7 pi over 2. This is telling me theta is between 3 pi and 7 pi over 2. Oh, it has to be in this third quadrant, right? Okay, so this is, I had to go around more than once, right? I had to go all the way to here and all the way to here, right? This is my angle theta. Now, what do I know about that angle theta? I know my y, this y right here is negative 4 square roots of 7. And I know this radius is 11. What I don't know is x, but I do know it must be negative, right? Okay, so how can I figure this x out? You can use Pythagorean theorem, right? So x squared plus negative 4 square roots of 7 squared is equal to 11 squared. So that'd be x squared plus, And this would be 16 times 7, which is 112, is equal to 121, okay? And let me slide that up. That would mean x squared is equal to 9, which would mean x is equal to plus or minus 3. But it can't be plus or minus 3 because of the location. X must be negative 3. Okay, so now I know this is negative 3 right here, right? Okay. All right, now because I know that's negative 3, and I can now find cosine of theta. Cosine of theta is just negative 3 over 11, okay? So back up here, all of that just to get started, right? This is equal to, okay, the square root, I'm not going to put the plus here now, okay? 1 plus negative 3 over 11 over 2, right? Okay, so we clean that up. That's the square root of 1 minus 3 over 11 over 2. Let me extend my fraction bar a little bit because this is a complex fraction. We're going to multiply by 11 over 11. And that's going to give me the square root of 11 minus 3 over 22. Okay, 11 minus 3, that would be equivalent to the square root of 8 over 22, right? Now 8 over 22 reduces because they're both even, right? That would be the square root of 4 over 11. Okay, so now we square root, right? So this would be the square root of 4 is 2 over the square root of 11. We could rationalize the denominator here because this is a good answer. It's the right answer. It's just not the best answer, okay? We're going to multiply top and bottom by the square root of 11, and we get 2 square roots of 11 over 11. And that's cosine of theta over 2. A lot of work on that, right? Okay? So that's an example of how to use the half angle identity, okay? As you get higher in math, the problems get a little bit longer, okay? All right? But you should be proud, right? Like, how many people can do this? Okay, that's the thing. How many people in the entire world can do this type of math? I mean, you guys, there's only 100 students right now, besides the calculus students, okay? There's only 100 students at Selma High that can do this, okay? Plus the calculus students, which is about another 30, okay? That's it. That's it. So be proud, like, I can do this stuff, all right? Be proud. Be a Selma Bear, okay? All right, let's do the next one. Okay, so this problem involves using the identity in order for us to solve something, okay? All right, so I have this equation, negative 2 plus 3 cosine of theta over 2 minus cosine of theta is equal to 0. And we only want the answers that the angle for theta that would give us between 0 and 2 pi, okay? So what we're going to do here is we're going to convert this, okay? So this is the half angle identity that we could use for cosine, right? And what's going to be nice about this is it gives us cosine, right? It's going to give us this cosine of the same angle, okay? So this is going to become negative 2 plus 3, okay? And I'm going to use a different color just to show you where I did use the trig identity, okay? This is plus or minus the square root of 1 plus cosine of theta over 2. Close the parenthesis. Okay, so I'm switching this cosine of theta over 2 with what I have in red here, okay? And then minus cosine of theta is equal to 0. Okay? Now, what I'm going to do is I need to get rid of this square root, okay? So what I'm going to do is I'm going to move this cosine theta over to the other side, and I'm also going to add 2. Okay, so what I'm gonna do is, like I just said, is I'm gonna move because the phone rang. Sorry, guys. All right, I'm gonna move this minus cosine theta and the minus 2 over the other side to make them positive, and then I'd have 3 times and then plus or minus the square root of 1 plus cosine theta over 2. Basically, what I want to do is I'm trying to get to I'm trying to get into this, right? So I just have trig functions, okay? Because I have all these other functions like the square root and the plus or minus and all that, okay? So this would be cosine of theta and this minus 2, when I move it over, becomes plus 2. And I can do that because I'm saying solve this, right? And I want to win what theta values make this true, okay? This should be a theta right there, okay? And then what I'm going to do next is I'm going to divide both sides by 3, okay? So that would give me plus or minus the square root of 1 plus cosine of theta over 2 is equal to cosine of theta plus 2 all over 3, okay? All right, so now what happens next, okay? So what I'm going to want to do to get rid of this square root, I am going to square both sides, okay? And when I square both sides, if I square a positive, I get a positive. If I square a negative, I get a positive, right? So I won't, that's going to be nice because I'm going to get rid of the plus or minus. It's just going to be square root. But why am I squaring? Because I'm getting rid of the square root too, right? So when I square this side, I'm going to get 1 plus cosine of theta over 2 is equal to cosine of theta plus 2 over 3 squared, okay? All right, now, something we talked about before, right here, when we square both sides, okay, by squaring both sides, we lost the restrictions on the domain, okay? And so what can happen out of this is we get solutions because we're going to get a quadratic here. We're going to get solutions to the quadratic. The original equation was not a quadratic, okay? So our solutions will be for the quadratic. Some of them, or maybe all of them, will work in this original function, okay? Or equation, okay? So basically we're doing this, I'm gonna say this, we must check all solutions, okay? Okay, so what we have from this is 1 plus cosine of theta over 2. Okay, if we square the numerator and we square the denominator, that's what the square would do, right? We'd have cosine of theta plus 2 times cosine theta plus 2 in parentheses. I'm going to go ahead and just write what we would get out of that because we should be able to do that. This would give you cosine squared theta, okay, plus 4 cosine theta plus 4 all over 9, okay? So cosine theta plus 2 squared, would, when you multiply it out, it would give you cosine squared theta plus 4 cosine theta plus 4, okay? So now what we're going to do is we are going to, because these are two fractions, right? We could cross multiply. We could also multiply both sides by 18, okay? If we multiply both sides by 18, 2 would go into 18 9 times. So we'd be left with 9 times 1 plus cosine of theta is equal to, if we multiply both sides of this by 8, right, this by 18, 9 goes in 18 twice, so we'd have 2 times cosine squared theta plus 4 cosine of theta plus 4. Okay, now on this side, we'd have 9 plus 9 cosine of theta is equal to 2 cosine squared theta plus 8 cosine theta plus 8. Okay, so now we have something that's called quadratic form, right? So we want to get one side to be 0. Now this cosine squared is positive, right? So I'm going to want to make the left-hand side become 0. So I'm going to move these over here, okay? So the left side's going to become 0. There's no cosine squared, so this is just going to stay 2 cosine squared theta, okay? Here on the right-hand side, I have 8 cosine theta, but I'm going to need to subtract 9 cosine theta. That would be, I'd be left with negative cosine of theta, right? And then 8, and I'm going to have to take away 9, so that makes minus 1, right? Okay, so I have like a quadratic, right? Okay, so And this is, we're going to have to use an area model to do this, okay? So the product that we're looking for, this is using a lot of stuff we've learned throughout the year, right? So the product that we're looking for is going to be -2, and the sum has to be -1. Well, -2 and +1. That -2 and +1 would give you a product of -2, but it would also give you a sum of -1, right? For those two numbers. Okay, so we're going to make our, because we're dealing with trig functions, we're going to make our area model just a little bit bigger than normal, more rectangular. Okay, so this is 2 cosine squared theta. This is -1. One of these is going to be -2 cosine theta, and the other one's going to be 1 cosine theta. So -2 cosine theta and 1 cosine theta, or you could also write cosine theta here. GCF across the top here is 2 cosine theta. And then right here is cosine theta. And then cosine theta times what would give you 1 cosine theta? It'd be +1, right? And 2 cosine theta times what gives you -2 cosine theta? -1, right? And then -1 times +1 gives you -1, okay? So this is zeros equal to, and this would factor into 2 cosine theta plus 1 and cosine theta minus 1. Okay? Zero product property, we would have 2 cosine theta plus 1 equals 0. We could also have cosine theta minus 1 is equal to 0. This would be when cosine theta equals -1/2, and this would be where cosine theta equals 1. Okay, where is cosine theta equal to -1/2? Well, where's cosine negative? Well, it's these two, right? Okay, so I'm going to draw my diagram to solve this. Okay, I know my x is -1 and I know my r is 2, right? The side links with, in this situation, this would be positive square root of 3, this would have to be negative square root of 3, and this tells me this angle is pi over 3, and this angle is also pi over 3. So my angles of rotation would be, slide it up a little bit, this angle theta that I'm rotating could be 2 pi over 3 or 4 pi over 3. Okay, over here, where is cosine +1? Well, that's 1 over 1, right? Well, that can only happen right here, right? Because right there, my x is 1, my y is 0, and my r is also 1, okay? Okay, so that would be what angle? That would be angle 0. Okay, so now what we have to do is we're going to check these in our calculator, okay? And we have to think, okay, dividing by 2 is the same as halving it, right? So we need to make sure that this comes out to be 0, okay? All right, so we can grab our calculator, okay? And what I'm going to do is I'm going to check. So -2 plus 3, and then cosine 1/2, right? 1/2, because that's the same as dividing by 2, okay? Times, and then let's try 2 pi over 3. Because that'd be 2 pi over 3 divided by 2. And then minus cosine of 2 pi over 3. And if this works, we'll get 0. And it does. Okay, so 2 pi over 3 is one of our answers, okay? So I'm going to go back and press enter there, okay? And this time I'm going to put 4 pi over 3. So I'm going to scroll over and put in 4 pi over 3. And just change those 4s to, or change the 2s to 4s, right? Press enter. That gives us -3. Well, guess what? I just used 4 pi over 3, right? And it doesn't give me 0. It actually gives me -3, right? So what does that mean? Back up here, I checked this in my original equation. It does not give me what I'm asking for, right? And it's because we squared both sides here, okay? So right now, this is not an answer, okay? So I'm crossing it out, okay? So what else could be the answer, okay? So back up here, could 0 be an answer, okay? So I'm gonna come back up here, okay? And this 4 pi over 3 becomes the 0, right? And this one, we could actually probably do this one a little bit easier in our head. So half of 0 is 0, right? And that one gives me 0, right? When I put 0 in for theta, right? That works, okay? So this one works and this one works. So we got 3 answers. And those 3 answers solve this quadratic. I mean, it definitely solves this quadratic, but one of them doesn't work, okay? All right, so our final answers would be 2 pi over 3 comma 0, and those are the only 2 angles between 0 and 2 pi that would work, okay? All right. Okay, so let's go on to the next example, okay? Okay, so for this next one, it's another solving problem, okay? And we want to solve negative sine theta plus cosine theta over 2. This is the same as 1/2 times theta, okay? And it equals 0, right? Okay, so what we have here is just an equation, right? And so I want to get this cosine theta over 2 by itself. Okay, so I'm gonna go ahead. Well, actually, I take that back. I'm gonna make this switch out right now. Okay, so negative sine of theta, okay, plus, okay, and cosine theta over 2, and I'm going to put a parenthesis here, becomes plus or minus, because we don't know which one, because we don't know where theta over 2 is, okay? Because if you do theta over 2, okay, it could be both positive and negative, okay? So plus or minus 1 plus cosine theta over 2. And this is my negative sine theta, this is my plus from right there, and this cosine of theta over 2 becomes this, right? And it equals 0, okay? So I'm going to move this minus sine theta over to the other side. So this becomes plus or minus the square root of 1 plus cosine theta over 2 is equal to sine of theta, okay? And now I'm going to square both sides, okay? And if I square this side, I'm going to get positive, and I'm also going to get rid of the square root, right? And I'm just going to be left with 1 plus cosine of theta over 2 is equal to, and when I square sine of theta, that means that would be equivalent to sine squared theta, right? Okay, now there's still a problem here, right? And here's the problem. We're dealing with sine and cosine, right? All right, and you really want, if at all possible, is you want to create one trig function, right? And there's no way you can switch cosine theta to sine, but there is a way to switch sine squared theta, okay? Because that's a Pythagorean identity. So I'm going to use that, okay? So 1 plus cosine of theta over 2 is equivalent to 1 minus cosine squared theta. All right? And I didn't say this, but right here we squared both sides, right? As soon as you square both sides, you can pick up extra answers by doing that. You can pick up answers that will work for the equation that you converted it to, but it doesn't work in the original one. So we're going to need to check our answers again, okay? All right, so now this is nice because I've got cosine thetas, right? All right, so now what I'm going to do next is I'm going to start working on my fraction. I'm going to get rid of this 2. I'm going to multiply both sides by 2. Well, that would give me 1 plus cosine of theta is equal to, and if I multiply this side by 2, I get 2 minus 2 cosine squared theta, okay? All right, and since this cosine squared theta is negative, right? Because it's negative 2 of them. I'm going to move everything to the left-hand side this time. So this becomes 2 cosine squared theta. Okay, this is the only cosine theta, so plus cosine theta. The left side I have 1, But on the right side, I have 2, right? So I can subtract 2 from both sides. So I get 1 minus 2, which is negative 1, and that's going to equal 0. Okay, and now I have this quadratic again, right? It's a quadratic form, okay? So we got to think of, okay, the product needs to be negative 2, and the sum would have to be 1, and that would be positive 2 and negative 1. So I'm going to do my area model again. I'm going to make it a little longer horizontally because I'm using trig functions. This is 2 cosine squared theta. This is negative 1. And one of these has to be 2 cosine of theta. And the other one has to be negative 1 cosine of theta. GCF across the top would be 2 cosine of theta. This would have to be cosine of theta. And cosine theta times what would give you negative 1 cosine theta? It'd be negative 1. And 2 cosine theta times what would give you 2 cosine theta? It'd be positive 1. And 1 times negative 1 is negative 1. Okay, so back over here, this factors into 2 cosine theta minus 1 times cosine theta plus 1 equals 0. Okay, so then we have 2 cosine theta minus 1 times cosine theta plus 1 is equal to 0. Okay, so then one of those is equal to 0, right? So 2 cosine theta minus 1 is equal to 0, or cosine theta plus 1 is equal to 0. This would be cosine theta equals positive 1/2, and this would be cosine theta is equal to negative 1. Okay, so where's cosine positive, right? And that happens in the first and also in the fourth quadrant, right? And I know my x is 1 and my r is 2. Again, this makes square root of 3, and this one would be negative square root of 3 because of the location. The angle would be pi over 3 for the triangle, the reference angle. So that would mean theta is equal to pi over 3, and the other one would be all the way around, right? Which this would be 6 pi over 3, and then I have to back off, so it'd be 5 pi over 3. Okay, where's cosine equal to negative 1? Well, that's negative 1 over 1, right? The only way for that to happen is right here. And x would be negative 1, your y would be 0, and your r would equal 1. Okay, so what angle would that be? Well, that'd be angle pi, okay? Okay, so we have pi over 3, 5 pi over 3, and pi. Do they all work? Or do only some of them work? Which ones work, right? So because we squared both sides, we got to go back and check, okay? All right, so I'm going to take my calculator again. And in my original problem, right, I'm going to do negative sine of pi over 3 and then plus cosine, and then that's the half angle, right? So I'm going to multiply by 1/2 instead of dividing by 2. And my theta is pi over 3. Okay, do we get 0? And we do, right? So pi over 3 works. Okay, I'm going to come up and copy it. How about 5 pi over 3? And we can insert. And that one also. How about pi, right? We got to delete the fraction bar. And that one gives you 0, right? So guess what? In this case, all 3 work, right? And you just don't know. You don't know until you start testing them, okay? All right, so for this one, all 3 are our answers, okay? All right, so that's it. We did some solving. We did some finding some exact values. We didn't do any verifying, we didn't do any identities other than like the first page I showed you where they come from, okay? All right. Now I'm going to be honest with you. The half angle identities are probably the least ones used. Okay. They are used for other things, power reducing, if you take more math classes. Um, but really it's the double angle that we're going to use several times, especially sine of 2 theta becomes 2 sine theta cosine theta. That's going to happen several times next year in calculus. Okay. All right, guys, let me get the assignment sheet and we'll talk about what I want you to do. Okay. Okay, so for today, I'd like you to do the half angle identities. So I want you to do worksheet TEI 9. Okay. All right, you guys, 2 more days, 2 more days, 2 more days. And you don't even have to worry about studying for finals. How's that? Great, huh? Great. Okay. The next couple days is going to be about solving. Today was kind of tough. I think today was tough, and I know it's kind of a long lesson. Okay. But the last few days have been kind of short. All right. So just kind of, it's the nature of the beast. Okay. All right, you guys have a wonderful day. You guys take care. Bye.